In this section 3.4, we will go over optimization problems, but in economics and science. So in the previous section, we mentioned that optimization problems can help us out in real life a lot, especially for managing costs in terms of minimizing costs and maximizing profits in business. And in this section, we will mostly focus on these kind of problems. So our first problem is a commuter train carries 2,000 passengers daily from a suburb into a large city. So I'm just going to highlight the important parts as I read through, which I see I have 2,000 passengers daily, right? The cost to ride the train is $7 per person, okay? Market research shows that 40 fewer people would ride the train for each 10-cent increase in the fare. So I know when I increase the price by 10 cents, I'm gonna get 40 fewer people. And 40 more people would ride the train for each 10-cent decrease. So I decrease the price, I get 40 more people. Okay. If the capacity of the train is 2,600 passengers and carrying fewer than 1,600 passengers means cost exceeds revenue. So this I see is an interval, right? So I see that this is going to be something along the line relating to my domain. So I'm going to highlight it. What fare should the railway charge to get the largest possible revenue? So this is the most important part. Now I have all of the facts. The only thing that it's asking is, what fare should you charge to get the maximum revenue? So I'm gonna write my function because it wants revenue in revenue, and I'm gonna write my function in terms of revenue and try to take the derivative from there. So the first thing is I know revenue equals, in this case, the number of people or passengers I have times the fare I charge for per person. That's why I get the revenue. Now I need to figure out function for each of these so that I actually have a function for revenue because they don't give us anything. Starting from number of people and how I can represent that, I know from the things they said in the problem right now that I have 2,000 passengers daily, right? So I can actually put that as a constant because no matter what, I know I have 2,000 people with no change. Now, the only thing that changes in terms of passengers is what's given right here, because depending on what I charge for the fare, my number of people that comes in uses the commuter train differs. So I can just choose one of these functions, which I'll end up choosing this one, and depend my function on that. So I'm gonna I get less 40 fewer people, but then I put a variable of x. So this x is going to represent an integer that represents how many people actually is coming or not coming. Same thing with the fare. So for example, why I put that x is if my x is, let's say, -1, I got x as -1 for the maximum value. That means I have 40 more people. Let's say my x equals 3. That means I'm not going to have 120 people that are not coming, so I'm going to get less than 2,000 passengers daily. So for this one, this does not mean I can only decrease it by 10 cents or I can only increase it by 10 cents, right? So it can be literally 30 cents, 40 cents. It depends on what my actual maximum is. Now on to the fare per person. Again, I have the constant given right over here, $7 per person. So no matter what, I'm gonna have that $7. The only thing that's gonna differ again is right over here, increase or decrease in the fare. So to make it constant, I chose this right over here, which is represented by increase 10 cents. So I'm gonna represent 10 cent increase by 0.10 given because this is by dollars. So I will say plus 0.10, but again, I put that value x because I don't know how much I'm going to increase or how much I'm going to decrease. So now that I have my function, all I'm going to do is distribute this into the other brackets. So when I do that, I'm going to get the value of negative 4x squared, negative 80x, and plus 14,000. And now I have my function. What I'm going to do next before taking the derivative is find my domain, find my intervals, right? And I know I said before is the capacity is given right over here, which is related to my domain. So because it only says passengers, so I don't have a capacity in terms of how much fare I charge to people. My capacity relates to how many people I can take in. And because number of people is represented by the function right over here, I'm going to use that to find it in terms of x, what my domain is. So what I mean by that, well, I'll start with 2,600 passengers, and that's my maximum capacity, right? Since my capacity is represented by the function given 2,000 minus 40x, since the most people I can get is 2,600, I'm going to represent it by maximum or equal to 2,600. Now I'm going to find it in terms of x, right? So I'm going to send that 2,000 to the other side as negative. So I will get the value of negative 40x and 600 because I did minus 2,000 right over here. So now I'm going to divide each side by negative 40, but remember, whenever you divide something by negative, you also change the sign. So I will get x changing the sign where it looks for, and now I have the value of negative 15. So this is one of them. I don't end here because I only use 2,600 given. That was my maximum capacity. Now I'm going to use 1,600 passengers given, and that's like I have to get 1,600 or more people, right? So I'm going to use the same function 2,000 minus 40x, but now I'm going to change the direction of the function. So I'm going to get 1,600 as my minimum. Again, I'm going to send that 2,000 to the other side as negative. So I have negative 40x. Same thing, and when I do negative 2,000, I'm going to end up getting negative 400. Now I'm going to divide each side by negative 40, so I'm left with x, but I change up the sign, so I have the value of 10 when I divide negative 400 by negative 40. So what I'm going to do with these, I'm just going to put them together so that I just have my intervals clear. So now that I have my interval plus I have my function, I can take the derivative now. So I'm going to represent the r in terms of x, right? And I'm going to take the derivative of this. So starting from the function right over here, my constant stays here, so negative 4. I'm going to apply power rule to my x squared by bringing that power to the front, so my n value. And I'm going to keep my x the same, and I'm going to do minus 1 to the power, which I will just end up with 1. Now moving on to here, I have my constant negative 8, which constant stays the same, and this is x to the power of 1, which if you apply the power rule, you would get x to the power of 0, which is a value of 1. So I'm just going to write it just in case. And for the derivative of a constant, it just becomes 0, so it's plus 0. And from here, I'm just going to distribute it, so I have negative 8x and negative 80 as my derivative. Now, we know from solving the problems in terms of maximum and minimum, what I do after having a derivative is equaling this value to 0 because my slope of tangent is 0 wherever I have the maximum or minimum points. So from here, I'm going to solve it for x. So send that 80 to the other side. I have negative 8x equaling to 80. And divide each side by negative 8, so I have negative 10. So before doing anything, whenever we have the x value, the first thing I do is check by the domain over here, and I realize it is in fact within the domain, so I do have the right value. So from here, all I'm going to do is plug in my endpoints as well as my critical point into my original function given, which is right over here. So now that I plugged in negative 15, negative 10, and 10 to my x values right over here, so when I just plug in, and I'm not going to write it, when I just plug it in into my calculator, I get the value of 14,300 for this one. I get 14,400 for this one, and I get 12,800 for this one. And because I'm looking for my maximum possible revenue, I need to look for the maximum value I have over here, which I see that it is in fact 14,400. So my X value would be -10. So what does that mean? That means if I plug in -10 for my fare over here, because it asks for what fare should I charge for the people, I'm going to get the value of 7 plus 0.10, -10. Yeah, over here. So I know when I multiply 0.10 by 10, I'm going to get 1. So that's going to be 7 minus 1, and I get the value of $6. So I should charge $6 each person, that's for each passenger. And what my 14,400 represents is my daily revenue. So my daily revenue would be $14,400. And let's say it doesn't ask, but let's say I also want to specify the number of people that's coming in. Again, I'm going to plug in -10 for my X value represented by my number of people, and I will get 2,400 people, which means it is in fact in my domain too, because my maximum capacity is 2,600 people. So that's the end of my question. So a cylindrical chemical storage tank with a capacity of 1,000 meter cube is going to be constructed in a warehouse that is 12 meter by 15 meter with a height of 11 meter. So first, before doing anything or reading further, I'm gonna try to understand what it means by this. So right now I have a cylindrical chemical storage. I'll try to draw it like something like this, okay? And this has a capacity of 1,000 meter cube, and it's going to be constructed in a warehouse. So this is inside of a warehouse that I'll try to draw it, something like this. And the warehouse itself, the height of it is 11 meters, and it's 12 meters by 15 meters. So 12 meters by 15 meters. The specifications call for the base to be made of sheet steel that costs $100 per meter squared. So I know my base is going to be $100 per meter squared. The top to be made of sheet steel that costs $50 per meter squared. And the wall to be made of sheet steel that costs $80 per meter squared. The first section is determine whether it is possible for a tank of this capacity to fit in the warehouse. If it is possible, state the restrictions on the radius. So the first thing I can start with is I know volume for the warehouse. I can find it from PR squared for the tank. Sorry, not the warehouse is the outside one and the tank is the inside one. So for the tank, it says this is the capacity. So the capacity is 1,000 meter cube. But how I'm going to find the volume for that is PR squared H, which I already know my H is going to be 11 meters. I'm going to do the volume depending on the warehouse instructions that I got. So height for the warehouse is 11 meters. So my tank inside cannot exceed that 11 meters, right? So I'm going to say H is my 11. For R, what I'm going to say is the value of 6. Why? When I look at here, R is represented by right over here, so half of it, right? If you look at 15 meters, if this whole thing, so diameter, is 15 meters for it to be fit, then my radius is going to be 15 divided by 2 to get the radius, and that will equal to 7.5. However, my radius cannot change, right? So I need to also do it by 12 meter. So for 12 meter, if my diameter is 12, then my radius is going to be 12 divided by 2, which is 6, right? The thing is, if this here, we count whatever is the lower, because if we counted 7.5, 7.5 cannot fit according to over here for this value here because 6 is smaller than 7.5. That's why I count my radius as 6. So if I plug it in, what I'm going to get is 1244 meter cube as a value. So what this value represents, what I found is the volume max. So max volume I can have inside of this warehouse. If you realize, we counted H as 11 because that is the maximum capacity for height. We counted 6 because that is the maximum capacity for radius. So since I know inside of this warehouse I can have a tank that is that has up to this volume, I know that original capacity of my tank is 1000 meter cube. I know it fits because it's smaller than 1244. If it was bigger than that, my answer would be no, it's not possible to fit this tank inside because it's bigger than the restrictions given to us. So for part A, I'm going to say yes, it is possible. And I'm going to state the restrictions on the radius, which I know radius cannot be more than 6. It can be up to 6. However, I don't know my other restriction. So I don't know, I can assume that it's 0, but I don't know that. Maybe I cannot have something smaller than a value that I'm going to find. So how I'm going to confirm the other value instead of just putting 0 is I know that my maximum height is 11 meters, right? So that stays. And I know the capacity of inside is 1000 meter cube. So what that means is for my tank, I cannot have anything less than 1000 meter cube. So it needs to be something either bigger than or equal to 1000 meter cube. And I'm just not going to put, what I'm going to trying to find is the radius. So I'm technically using the same volume technique, which I know this equals PR squared H, right? And I can technically put the values I talked about. So I have P, I don't know my R, that's what I'm trying to find. I'm going to put 11 for the H. However, what I'm going to say is because of my capacity given for my storage tank, this is going to be bigger than or equal to my capacity, right? I'm not going to have smaller than given capacity 1000 meter cube because what they told us is, can this fit in? I have a capacity of 1000 meter cube, but if it's bigger than that, it's okay because we also calculate the max capacity that it can fit in. So for the radius, now I can find a smaller section. What I'm going to do is divide each side by 11 pi, which I'm going to end up with r squared, and as an answer to 28.94. And then I'm going to take the root for both sides, which I'm going to end up with 5.38. So now I know that my other radius is going to be 5 and equal 5.38. So it's not 0. So that's why it's important to also check the other value instead of just putting 0. So now that I have my capacity and everything, the second section is saying if fitting the tank in the warehouse is possible, which it is, determine the proportions that meet the conditions and that minimize the cost of the steel for construction. And all calculations should be accurate to 2 decimal places. So from the question, the first thing I need to come up with a function, right? And because it says minimize the cost of the steel for construction, it's going to be a function depending on the cost, and it's going to be on the on these values given, right? So I'll start with a cost equaling to, like always, I know, let's start with cost of my base, right? So cost of my base is $100 per meter squared, but I know this is for base. So what I will do is, because it's per meter squared, I'm gonna have $100 and multiply that by the area. So area for my base is PR squared. So now for the cost for my top, I know it's $50. So same thing, the area is going to be the same. So I'm going to put $50 PR squared. And for cost for the wall, that's where the area differs, but it's going to be the same thing. So cost for the wall is $80, where I'm going to multiply by the formula given for its side, which is 2 pi RH, right? So for the cost itself, what I'm going to do is I'm going to add all of these up and put it as an equation. And I know over here, because these are the same, I can just add them up and have I'm not going to put the dollar sign because it's a function. So I'm just going to put the value, which is 150 when you do 100 plus 50. And I'm going to have the same value of PR squared, right? And over here, what I'm going to do is I'm going to distribute that 80 to here, which I'm going to get plus 160 PRH. Now, because I want this in terms of R, so this function over here is technically cost in terms of R, right? But I have H value over here. I can actually replace this at H value by what it's given to me. I know the volume of the tank is PR squared H, right? It's represented by this. And I know the capacity of it is 1000 meter cube. So I can actually equal this to 1000 and find H from here. So if I divide each side by PR squared, I'm going to get H equaling to 1000 divided by PR squared. And I'm going to plug this value in for my H. So I'm going to get my CR as 150 PR squared plus 160 PR, and my H value is going to be 1000 divided by PR squared. I also realize now I can actually cancel these out, and I can cancel one of the R's for this. So I ended up with, for my function, 150 PR squared plus, I'm going to multiply this 160 by 1000. So I will get 4 zeros divided by R. So here is my function. So now to find the critical point, because it's asking for us to minimize the cost, so I'm looking for the minimum value, I'm going to take the derivative of this function, right? So I'm going to keep the constant 150 pi, because pi is also a constant, and I apply power rule to the r squared by bringing 2 to the front, keep r, and when I do minus 1 to the power, I only get 1. Over here, this here can be written as the constant in the front and r to the power of -1 because it's at the bottom. So if I take the derivative of this, I'm going to keep the constant. And then I'm going to apply power rule to this one by bringing -1 to the front, keep r, and we do -1 to the power, which I get -2. Now if I put this all together, I'll end up with 300 pi r, and negative just bring it to here, so I have negative 16340 zeros, and then I have r to the power of -2. Now what I'm going to do here is equal this function to 0, which we did before, to find the minimum. So I'm going to send this one to the other side, so I will end up getting 300 pi r equaling to 164 divided by r squared. So I put that r to the -2 to the bottom to make it easier on us. So from here, because I need r's on the same side, I'm going to multiply each side by r squared to get rid of this. So now I'm left with 300 pi r to the power of 3 equaling to my constant. Okay, now I'm going to divide each side by 300 pi to leave my radius alone. So now that I have a constant, I can actually take cube root for each side to end up with, if you put it into your calculator, you'll end up with the value of a radius 5.54. So now that I have my critical point, all I need to do now is have this and my end point plugged back into my original function. So if I plug these values back into my original equation, which is what we found before, so I rewritten it here. So if I plug this into my calculator, I'm going to get a value of 43,380 for this one, 43,344 for this one, and 43,631 for this one. So because it says minimize, I need to find the value that is the smallest between these three. So I know the smallest value is this one right over here. So that is going to be my answer. Since it says determine the proportions of it, I know that my radius is 5.54 meters. So that's my radius given. I know my cost, which is going to be 43,344. That's what it represents. Now, another dimension that it wants probably that we need to find it is height. So I know we said before it didn't fit in here, but we said height will equal to 1000 all over pi r squared, which I can plug that r back in here to end up with a value of 10.37 meters. So these are my values. These are going to be my answers basically for this question. So for this problem, it's actually easy, but it might sound confusing at first. So if the cost of producing X items is given by the function Cx, and the total revenue when X items are sold is Rx, then the profit function is given by over here, which we used before previously too. Show that the instantaneous rate of change in profits is 0 when the marginal revenue equals the marginal cost. So starting from here, it says show me the instantaneous rate of change. We know that that equals to taking the derivative of it, and it wants me to show that in profit is 0, so we need to equal that to 0 when we found that maximum versus minimum. And it's basically saying that prove that marginal revenue, my revenue is going to equal my cost. So now if we were to take the derivative of this for a function, we would be saying p prime x, and we will be taking the derivative of here as well. How do we take the derivative? We just put the prime over here because we don't know what the function is for this one. So minus c prime x, right? Now that I have my derivative, what we did before in maximum minimum questions is we equaled this to 0. So from here, I can actually find what my revenue equals to by sending this to the other side as positive sign, right? So technically my revenue, derivative of my revenue will equal the cost. But since these revenue will show me the marginal revenue, this is my marginal revenue. And in fact, this is my marginal cost. So in fact, from here, it wanted me to show that marginal revenue in fact equals marginal cost, and we showed it right over here. So it's a very short problem. That's it. That's the end of it. Because especially in this section, there was a lot of problems that differ from each other. I encourage you to solve a lot of optimization problems within or your textbook or whatever your teacher gave you. But if you have a problem that you couldn't solve, you can always go to our website and go to the forum section under MCV4U, and we can help you there to and give you the solutions to the problems with step-by-step solutions.